Good morning, everyone. Afternoon, in fact. Welcome to the first seminar of this academic year. It's lovely to see such a full turnout here in the room. I know there's also a watch party upstairs and many people also joining online. So it's great to have such a good audience, as is fitting on the day that the Physics Nobel Prize was announced in the field of artificial intelligence. My name is Sarah Parrott. I'm the Associate Director at the Faraday Institute. So I'm glad to meet you today. We're delighted to have Thilo Stadelmann as our speaker today. He'll be talking on the title, Artificial Intelligence, A Tale of Two Meanings. Thilo is Professor of Artificial Intelligence and Machine Learning at the Zurich University of Applied Sciences, ZHAW, School of Engineering in Winterthur. He's Director of the ZHAW Center for Artificial Intelligence and head of its Machine Perception and Cognition Group. He's a computer scientist with a PhD in multimedia analysis and voice recognition. Thilo worked in the automotive industry for 3 years prior to switching back to academia. His current research focuses on robust deep learning to solve diverse pattern recognition tasks, such as biometrics, document analysis, and computer vision for the industrial and medical applications. And this is what we'll hear more about today. He has many honors and awards, but I don't want to take up too much time away from his talk, so I'll invite Thilo to come up now. In terms of questions at the end, people in the room will be able to put their hands up and I'll pass you a microphone. For those of you online, you can type in your questions in the Q&A box. Thank you.
Thank you very much, Sarah. Thank you very much, my beloved audience, for being here today. I feel a little bit intimidated, so many people. Wow. We will be speaking about AI, a timely topic, a topic that is currently everywhere in the news. And we will try to do three things. First, what is AI from a technical point of view? Where can it be used in businesses and the like? Why is it useful? And then we will look and spend some time on the more broader implications. What does it mean for us as humans? What does it mean for us as society, potentially? How can we come into a hope-filled future, including such technologies? That's a plan. Are you with me? Fantastic. So, as Sarah already said, I'm a computer scientist. Computer scientists are typically not invited to give speeches directly after lunch because, well, we are boring. I try my best not to be, but bear with me. AI, what is it? There are at least 2 times as many definitions of the field as there are researchers in the field because, well, we cannot decide. There are so many good ones. This is one I like very much. AI, the mimicking of intelligent behavior with a computer. I like it because intelligence is part of it in the right way and probably in a different way than we think. If you would paraphrase that, it probably would sound like AI is about faking intelligence. It's about mimicking the result of what we would do with our intelligence with that of a computer. So there is not a single uniform theory of what intelligence might be, what it might encompass, or how to build it. What we have is much more like grandfather's toolbox, with a lot of different methods and tools to simulate intelligent behavior, intelligent outcome for different kind of scenarios or problems. One of these tools, if you're a little older, you may know, in the 90s, there was a famous chess match, IBM Deep Blue versus Garry Kasparov, then the world champion in chess, who lost the match against the computer. The newspaper's titled, now humanity can step down, computer won in chess, so there's no much more to gain for humanity, as if chess would be what defines humanity. Well, I mean, we play it because it's difficult for us, right? Not because we're so good at it. Anyway, the method that was used by IBM was a method called fast search algorithms that lead up to formal logic and stuff like that. How does that work? It looks at every possible move the computer can make, all the possible returns that Kasparov could make, all the possible returns for every possible return that the computer could make, and so on. as much compute time as there is. And then finally, if it knows everything, pick the one that is likely the best. So Young would say that's brute force and not very intelligent, but it creates intelligent behavior. And that is what it's about. It's not about mimicking the process by which we humans arrive at a result. It's mimicking the result itself. So that's still one of the very important techniques of AI. You probably used it today or this week already when you use a navigation device in your car or on your phone. I used it when I tried to find my way to Cambridge here. These kind of routing algorithms use exactly the same methodology. But we wouldn't be talking about AI today, and probably the Nobel Prize wouldn't have been awarded today to two physicists doing AI research if it was only about formal logic and clever search. We are talking about AI because there's also another side of the toolbox where we have machine learning. So what is machine learning? Specifically, one sort of machine learning in larger neural networks called deep learning. These are methods that also exist since many years already, but became more prominent to a wider audience around 2012, when they were able to tell the difference in images from cats to dogs. Now, why is that an important thing? Well, because it's difficult. If you would try to write down, like logically, step by step for a computer to follow, how to distinguish a cat from a dog, you realize that's not an easy thing. You would probably say, well, a cat has these whiskers and a different kind of fur, but how to put that into precise words and how does it map to the pixels of an image? It's difficult. I mean, if your cat burns its whiskers, it's still a cat, right? Even if it doesn't have whiskers. And if it doesn't have fur because it's a naked cat, one of these Sphinx cats, it's still a cat. So there are so many exceptions. It's very, very hard to code that in rules. And here, machine learning comes to the rescue. What is machine learning? It's a technique that basically learns, and we will just see in a minute what that means, the relationship, the functional relationship between an input and an output. Mathematically speaking, and we all had this at least in school, even if we're not trained scientists, mathematically speaking, that's a function that maps an input onto an output. So what machine learning actually is, it is the adjustment of the parameters of such a function so that the input will be related to the output. Imagine the simplest possible function that you learned about in school, the linear function in 2 dimensions, right? It has 2 parameters, the y-axis intercept and its angle, the steepness. Right? These are the 2 parameters of the function. And by manipulating these 2 parameters, you get every possible linear function in 2 dimensions. And exactly this is what machine learning is doing. It is fiddling with these parameters, changing them in a structured way so that input in a numerical form is mapped to output in numerical form. Here's an example of how that looks in 2D. We have, for example, the red dots, cat images, the blue dots, dog images, and line a function that should separate them. And we see first a random line, and then the 2 parameters are changed in a structured way so that it better discriminates between the 2. That is what machine learning is doing. And this is actually also what large language models are doing, because it's also based on that principle of learning the parameters of a function. Here, we are learning images, pixels, to a label, cat or dog, or for the dog people, dog and cat. Here, it's learning many words, a context of words, to be mapped on the next probable word based on the whole vocabulary of words. But it's still machine learning, learning the functional relationship between an input and an output. So that's the second side of the toolbox. And this is where basically every AI method that you currently hear about in the news, and that is so super exciting and so very awesome in its results, is based on. It's learning based on lots of data. We give it, let's say, 1 million of such images and the respective labels, as we call it. And based on this, we tune the parameters of the function so that it works for this 1 million training examples. And we assume if it works for this 1 million training example, that it would also extend or generalize to the 1 millionth and first example, and then the next and the next, as long as these next examples have some likeness of what we saw in the training data. Good. So this is what AI is based on. Now, what's the result of this? Well, something that is definitely different from how we humans work, how we humans learn. Probably when you heard that for the first time and I was speaking about learning and using words like this, you thought, well, that's not what I thought how learning and intelligence in computers works, because it's so different from what we have. Yes, true, we don't, as computer scientists, we don't have good words for that. So we use borrowed terms we normally use for our learning, for our understanding. In the computer, it's completely different, but it can be very good. On average, these statistical models outperform humans on almost every task we use them for, from image recognition to speech generation, and so on. So it can be, on average, be very, very good, and still in every individual case be wrong. As an example, you already looked probably at that moving image here. What do we see here? A cloud of points. They all look completely distinct, including a strange dinosaur, and a simple statistical model giving us the mean and the spread of the distribution of points. And you see, up to the second digit, the model is exactly the same for all the points, meaning the same completely different data can give rise to the same statistical model. If I now use the statistical model to generate new data, it can look like any of these distributions and has nothing to do with maybe the one we trained on. So let's keep that principle in mind and look at an example. That's an example of GPT-4, GPT-4o actually. So one of the best current chatbots from OpenAI. And we gave it a very simple task. You probably know it. It's something like for humans, as humans, it's something like a brain teaser. And it's the riddle of the man and the goats and the vegetables. And it goes like that. There is a man and a goat and a couple of vegetables and a boat and a river. And the man wants to get his belongings to the other side of the river. The only problem is if he leaves the goat and the vegetables at any place alone, the goat will eat the vegetables and the man will have lost his property. So the riddle is about in which order does, and of course there's a constraint on how much he can load into the boat. So the riddle is about in which order does he need to load and unload stuff into the boat and bring it to the other side, so that in the end, everything is on the other side of the river, and the goat didn't eat the vegetables, right? You know it probably. Now, we asked a very, very simple version of that riddle to GPT-4o, the highly acclaimed model. And the very simple version is, there's a man and a goat and nothing else, and a boat and a river, and no constraints. How does it get to the other side? And now GPT-4o says the following. Yeah, it explains that this is a test and what the initials, so it recounts everything, and then says, these are the 3 steps. First, load the goat into the boat. Drive to the other side. Unload the goat. And now, go back on the other side of the river, get out of the boat, get into the boat again. Get to the other side of the river, get out, now you're done. So one empty drive over the river. Why that? It's completely stupid and unnecessary. Well, because I guess in the training data of GPT, it has seen thousands of examples of this going back and forth over the river many, many, many times. So statistically, it's completely implausible that this should be finished after the first thing. And you remember, it doesn't think. The principle behind ChatGPT and LLMs is predict the next probable word. And it's given the training data not probable that the riddle is over after the first crossing of the river. So it statistically hallucinates a second turn that is not necessary logically. So we have to keep this in mind, that we have with machine learning, we have to do with statistical models that have their great advantages. I don't ask if you use ChatGPT and if you find it useful. I guess you all found it useful for something. We have to keep in mind that it's a statistical model that also has shortcomings when we see these amazing results that blow our minds. For example, like this one here. That's the Joker, live performing a rap song. Of course not. That was Lil Yachty here in a concert in the US. And he was replaced from a single picture of the Joker by an AI system that could manipulate videos and a little bit of Photoshop work, 8 minutes work for somebody who can use AI systems in Photoshop. And that's amazing stuff like that, that a computer vision system can analyze the pose and the lighting here and transfer it on an image and animate it in a way that it looks like real. Like when I saw it the first time, I had to find out which one is a real and which one is a fake. We have both. We have amazing results and shortcomings that are fundamental because they lie in the method. They will not just go away with the next model iteration. Okay? Now, this stuff is useful. It's useful in a lot of different domains. It's useful on text. It's useful on image data. So it's used a lot, specifically professionally in business. We see here a figure that I copied from a paper from a colleague from Harvard. He conducted a study with professional desk workers, knowledge workers, like probably many of us are. And he asked specifically not about the quantity of their work with and with AI, no, about the quality of the work. So this is a quality axis, and the blue curve is the quality of the work of these professional knowledge workers not using AI. And the mean of their distribution is around 4, whatever 4 means here. The interesting thing is that when these people are given access to generative AI systems, quality rises from 4 to a mean of 6. That's basically 50% more quality, not quantity. So this is why people are like bullish about the technology, and there's a lot of hype and money in the system currently because it works pretty well. Here, also from Harvard Business Review, is an overview that you probably cannot read. I even cannot read it from here. With 100 different use cases people use generative AI for in business, from summarizing text or producing a draft of an email to creating strategic scenarios for the board to decide in which direction to go. Very, very interesting and creative stuff in here. I will just pick out one. An interesting use case that is also supported by my company, but that was it with advertisement. Say you are working professionally in a company and you want to use a large language model for something. Chances are you're not interested in some general world knowledge of this model. You do not want to ask about the weather or stuff like it. You want to use a model on your proprietary data and your confidential information within your organization. Now, the problem is you do not want to, this information is not public. It's not part of the training data, so the model doesn't know it. How do you get it into the model? The answer is the fastest growing paradigm in software development that computer scientists have seen in 50 years, outperforming in terms of how fast was it adopted every other method to develop software. It's called retrieval augmented generation. What is retrieval augmented generation? You couple two things. You couple a search engine, an information retrieval system that works on your documents, on your pool of knowledge, everything you have digital in your company. So when you ask a question, first it goes to the retriever and it crawls for documents and pools of these that are likely containing stuff that contributes to the answer. Now imagine if you use Google or any other search engine, this is what you get as a result, as if pulling up a document and saying, well, the answer could be in it, would already be an answer. It's not, right? So retrieval augmented generation takes it one step further. It takes all these documents that the search came up with and puts it into a large language model, a generator, into the context window, into the prompt of the large language model, and asks it to answer the original question only based on what is now in the context, not using its world knowledge and so on. What you get is typically a result that is based on your confidential data without the need of sending the confidential data out to any cloud service or so if you run it on your own hardware. And it reduces the risk of hallucination. So the results are, I wouldn't say completely truthful. It's still a statistical model, but it's more truthful than if it just generates out of what it has learned by reading all of the internet. So this is one thing companies are, and any kind of organizations, also governmental organizations, are currently doing a lot to use their internal knowledge, their digitized internal knowledge, and the new technology based on large language models. Good. Now, we talked a little bit about generative AI, but AI is much more. I told you, you remember, right? The toolbox, there are a lot of tools in it. Generating data, generating text and images is just one tool in it. So there's a lot more. And before we go into the more overarching things, I want you to see again the breadth of the field and of the solutions. So you probably saw this from a London-based Google part, DeepMind, a couple of weeks ago, the newest month ago, the newest iteration, AlphaFold 3. is a machine learned model that has learned to solve the protein folding problem, which was known as one of the most important scientific problems of the last century. And it's not completely solved, but there's an approximate solution good enough to be useful for certain applications already. This model, given the sequence of any protein, can predict to a okay-ish accuracy the three-dimensional folding of the protein. If you know the three-dimensional folding, you know much more about the potential properties of this molecule than if you just have the sequence. Most of the properties are determined by the folding. So if you have access to this tool and you're, for example, a pharma company, and you want to have a drug with a specific use and not specific and random side effects, you can take all your candidate sequences, throw it at the model, and ask, okay, which ones are the most likely ones having this effect and not these side effects? So you get your search space down from a couple of billion potential molecules down to, let's say, a couple of thousands, which you can synthesize in the wet lab. So something like this is super, super useful and has been built using machine learning technology. So this similar to what we saw in the beginning, learning the function. But AI is also used for other kinds of data analyses. Here we see how the game of basketball changed between beginning of the century and now 45 years ago, based on people using data analytics to find out what makes sense if I want to be the winner of the NBA. And we see the model found out it doesn't make sense to shoot from the midfield. You either do a dunking or you do a three-point shot. Everything else is a waste of opportunities, according to the model. So sports changes because data analysis brings up insights about what works and what doesn't. Here we see an image segmentation model. It's an open model called SAM, Segment Anything, from Meta, so the Facebook owner company, that has been trained on a lot of images, similar to ChatGPT and these large models, to segment foreground or to tell foreground from background, so to segment objects. And it has done this on a lot of different kinds of images, real photos and unnatural images, for example, for medical imaging. And this can now be used and adapted to any use case you have. It's open source. You can just take it for your internal use. For example, I saw studies that just taken as it is, it's not very helpful for medical imaging. But if you just fine tune it a little bit and put some more smartness into it in the orders of a couple of weeks or months instead of years it takes to build such a foundation model, you can use it for medical imaging as well. And certain tasks you build into. So this is something we also use in our research to bootstrap the process of building helpful systems. This is an example of image generation from the newest model from the latest startup, actually from Germany. Who would have thought that? Black Forest Labs in the Black Forest, the model Flux One. What is amazing about this, I mean, you probably saw computer AI generated images and how great they can look like. But typically they have problems when it comes to fine-grained details. What is amazing about, truly amazing about this image is the text. It's not just, you can not just read it, it also makes sense. So this fine-grained control about generating images, including text, wasn't possible until, let's say, 2 months ago. That's truly amazing. AI still has a lot of other things in it. For example, what we see here is an approximate solution to a traveling salesman problem. A traveling salesman problem is the penultimate hard problem in computer science. If you can solve this, you can solve any hard problem at least as good. What kind of problem is it? Well, you want to visit every red dot exactly once with the shortest path. Computing this is very, very hard. And if you have many red dots, it's intractable mathematically. You don't find a solution that computes within a reasonable amount of time. Using AI and learning and approximation, we can find an approximate solution that is maybe not perfect, but almost. And you can find it very, very quickly just by simulating and taking randomness into account. Final thing, this is a robot. from a Zurich-based startup called Anybotics, a spin-off from the ETH. And they have used machine learning for its gaits, so that it learned to walk more dynamically. What is great about it? Well, if you compare this to how a robot was walking in the 80s, it's a little bit more smooth. Why? Because it's not anymore programmed to walk. It has learned to take dynamically the environment and all the properties of it into account. And it has learned a functional mapping between its sensing of the ground and its walking and its objective to, for example, reach a certain point. And that works much better than us humans trying to program every eventuality. So these are all examples of what AI can do today beyond ChatGPT and image generation. Good. So where will that lead to? Beginning of last year, I was putting out my first opinion piece on LinkedIn and found myself writing that the moment after ChatGPT was released can probably be likened to the moment when the internet was first made public, the World Wide Web. You see here Tim Berners-Lee in his office at CERN in Geneva, Switzerland, where he showed the World Wide Web to the world. And some people saw, oh, that's a big chance. But I think even these early adopters didn't see it coming, that only 20, 30 years later, basically the internet, a network between computers, would have become the only and unified portal to almost all our social contacts and all our media, which is what the internet today is, amongst many other things. Maybe also the unified portal towards most of our commerce. So this was not completely obvious when people looked at these early web browsers and blinking magenta colored fonts and stuff like this. So if this, the ChatGPT moment, if this is like this, then what is like this? That's the question, right? So my personal guess, and now there are a couple of other people who think so as well, for example, Bill Gates. I'm very thankful to Bill Gates for having the same opinion as me, or the other way around, I forgot, is that we will have, let's say in a foreseeable future, if that is 3, 5, or 7 years, who knows, something like, the scientists call it agents, AI agents, that can work as personal assistants, with whom you can communicate in somewhat normal language, and they can do reasonable tasks for you on the level of what a capable human assistant could do for you. For example, dear computer, my niece has her birthday in about a week, and I forgot about it, and I have no time. Can you please look up for a present and maybe order it? And maybe you can even draft me a card that I can use to invite it myself. Thank you. Consider it done. Something like this should be, for things that can be done digitally, should be possible. And it should be possible without any super intelligence, without any artificial general intelligence that can overrule us and whatever. That should be possible just as a tool. Now you might ask, how is that possible? Think about what we currently have, and you see a glimpse of it with the newest version of OpenAI's model, the 01 model of ChatGPT. It's called agentic design patterns. Imagine you have a large language model here, this avatar here, that is asked to please write some code. So the large language model comes up with, for a certain problem, write computer code. So the large language model comes up with computer code. And as the typical output of a large language model, it will be probably helpful for an expert, but it will likely not run. It will have bugs, and even if it runs, it probably has weaknesses. It can be attacked easily by a hacker and so on. So if you ask for something and you get directly the result, it's probably not a good result. But now if you have a second large language model and you allow the two of them to ping pong with each other a potential answer and improve it, and only maybe after 10 minutes and 10,000 iterations among themselves, come back to you with the final result, it will probably be very much improved. Exactly, this is the new principle behind the 01 model. It now, the techies call it inference time compute or test time compute. So it does not directly from your prompt go to the next probable word and the next probable word and so on. it creates something, it criticizes it itself, it recreates, it criticizes, recreates, and so on. It writes its own prompts for a while, let's say for 1,000 steps or 10,000 steps, and only after that gets back to you with the result. And that improves the result dramatically. It still hallucinates, it still doesn't think, it's not conscious, and so on and so on. But it's very helpful. And this will bring us these kind of agents that are helpful for a lot, not for everything, for a lot, in a foreseeable way and manner, in a foreseeable time. So this is what we're heading for, realistically. Now, there are also these headlines, right? Ray Kurzweil, who is not a stupid guy, writes about transcendence and the age of spiritual machines and the singularity. Others see a lot of dollar signs in their eyes and say, wow, we will all get rich or die trying. There are a lot of dreams and nightmares about AI. Are they based in what we just saw, like mimicking intelligent behavior with a computer? Or is there something else behind it? What did I conceal from you? Well, and I have to tell you the truth, I did conceal something from you. Namely that there is a second meaning of the term AI. The same 23 characters are used for something that has nothing to do with the real technology we talked about in the last 29 minutes. The term AI is the description of a scientific field of existing technology, and the term AI is, in the best sense of the word, an empty phrase to be filled by whatever since the inception of science fiction literature, so even longer than the field of AI exists. The term AI has been used by people to describe futuristic ideas, completely independent from what is researched and what we have and what is developed. And these both meanings intermingle, which normally is not a problem. We have that in many terms. For example, a black box is the thing you have in a plane. When it crashes, you can somehow reconstruct what went wrong. And a black box is also a term that is used for things we don't completely understand, like AI systems. The one meaning of black box has nothing to do with the other. But normally it's not a problem. It's completely separated. This is not separated. The same people who are talking and developing the technology are also talking about potential futures, visions, fears, dreams in the same article. And it's very hard even for the specialists to disentangle these two meanings and find out, okay, when is a person now speaking from what perspective? Are they speaking about the science fiction thing, or are they speaking about the science and the technology? So let's talk a little bit more about this second meaning of AI. What kind of worldview, as I said here, is behind these wildest dreams and nightmares that appear in our news outlets and on our inboxes when we read newsletters and so on? Emilio Torres and his colleagues found, because they thought we need to have a term for it, otherwise we cannot talk about it, found an acronym for it, or created an acronym for it called TESCREAL. It's not a real word, it's an acronym. It's an acronym for transhumanism, extropianism, singularitarianism, cosmism, rationalism, effective altruism, and long-termism. These are all worldviews, philosophies. Let's take them apart very, very briefly. I'm not a philosopher. I'm a computer scientist. And try to figure out how these philosophies, if you subscribe to them, give rise to dreams of dollars and whatever, utopias and dystopias, nightmare. It all starts, and they're not in a good order. I guess they put it in an order to get something that you can pronounce. Let's take them in an order that somehow shows us how the argument is constructed by these people. And it's a worldview that is predominantly held by many, many people in the tech industry that live near San Francisco. So this is somehow a Californian phenomenon and shouldn't bother us too much. Problem is, a lot of this technology is shaped there. So with the technology, also these thoughts are exported. And I think it's important to know about it, because otherwise we cannot truly understand what these people talk about when they speak about their technology. I mean, we now know what the technology means, but we also have to understand the other side. to disentangle the meanings. Okay, task wheel. It all starts, I would say, with rationalism, with the idea that whatever we cannot grasp with our mind and sense with our senses isn't real and doesn't need to be considered. You could also say materialism brought to its extreme. If you have this, then you have, interestingly, very low regard for life and for humans. Because in the end, humans are kind of biological computer on carbon-based hardware. Consciousness is something like having an internal state variable, and it could all be simulated. Now, if we combine this with the second thing, singularitarianism, the idea that, or the observation that, well, technological development is fast, and you extrapolate that, and you come to the idea that it's exponentially fast. So you conclude that it will reach infinite heights in finite time. And well, we talked about that people from California have these ideas. So in California, you anyway have a mentality of, let's do it, we can do anything we want. So if you combine rationalism with singularitarianism, you end up with the notion that, well, why shouldn't AI be conscious, alive? They don't really say alive, but this is, I think, the implication of it, in about 10 years or 40. And if you want to raise the next 10 billions for our company, maybe let's bring it down to 12 months. That's much better for the pitch deck. So you have some fantasy of feasibility. And based on this now, you put transhumanism. So why should we bear with this decaying body of ours? It's just a commodity that maybe we do not need anymore. I mean, if we're a computer, and the main thing is anyway our spirit or our mind, why not find a way to upload it into some cloud and have fun in the metaverse? This body needs to be sustained, it needs to be washed, it's all messy, and let's do away with it. Now, well, if you have done this step, we need a lot of compute for the metaverse because, well, it needs energy. It runs on computers, silicon-based computers. So we probably should find more energy sources. Where do we find it? Oh, we find it in space. We have extropianism and cosmism, which tells us, let's go to space and build Dyson spheres around stars that bring us a lot of energy. Then we can build computers on planetary size. So we have a larger metaverse and we can have more people. And we add to it long-termism. Our vision is not for the next 100 years. Our vision is for the next 100 million years. So in 100 million years, we could have trillions of people, not these people, like real people, minds in the metaverse, not bodies. So we can have trillions of avatars on planetary-sized computers that will all be super, super happy. If only we don't mess up now. Now comes effective altruism, a movement very, very popular since 10 years, maybe, specifically in the US, that basically says, in the beginning, I think is a good thought, like we should be helping each other, we should be altruistically motivated, and we should measure how good we are doing, because then we can improve, like in business. In business, we have KPIs, right? So we should have KPIs in our doing good as well. So what could be a KPI for doing good? Well, what the engineers, these are mainly engineers, came up with is the sum of happiness, or the integral over happiness over all ever lived lives. Make sense? So now if you have a time scale of hundreds of millions of years with trillions of lives, metaverse lives, down the line, what you have the first couple of 100 million of years doesn't matter too much because we're not so many. So if you're an effective altruist, you don't care about people today because you care about the avatars. And that means if there is anything you can do today to make it a little bit more likely that this utopia will happen, for example, we need more research, more compute, more energy, more water to power more of this AI systems we're currently building, then probably we should bend out resources towards this. And if that means we can not feed the poor, not prevent wars, burn the planet, whatever, and a couple of million die today, that's probably okay. And this is why Torres and his colleagues say this is basically eugenics in disguise in the 21st century. And I wonder why people would ever subscribe to it. It's actually pretty ridiculous. But this is the worldview of a lot of people who are developing our technology today. And it leads to interesting things. For example, it's leading to fears. And you probably heard these statements from people like these, but there are others as well, that say, I really, really fear that this could be the end of humanity. Why? Because there might be if you have an exaggerated fantasy of what is feasible, because, well, life is not so special, it's just computation. Computation we are in charge of. It will probably only be a couple of, what did Sam Altman say last week, like a couple of thousand days until we are there. If you have this exaggerated feasibility fantasy, and then you think, oh, and there's a tiny, tiny, tiny probability that this goes wrong, that we will build a system that will be something like alive, without using the term, which could turn against us. And then all these trillion avatars will never exist. That would be a pity. And so they put out letters to stop research on it. They say, oh, dear government, please regulate every other company except us. Yeah, and you can look it up. Elon Musk basically said on long-termism that it's a close match for my philosophy. The biggest venture capitalist who is backing all these startups basically had in his Twitter, now X, profile, I'm a test realist. So that's not made up. So that's a worldview that is powering these ideas, not the technology itself. That's science and technology, but this idea, in which direction is it heading, what will come out of it. That's powered by worldview, and I'm very thankful to these colleagues and others for making that very plain. If you listen to Max Tegmark, director of the Future of Life Institute, professor at MIT, talking 3 hours on why he put out that letter to drop this moratorium on AI, he basically brings not a single scientific argument, and he's plain about it. He says, that's my worldview. That's why I'm scared. And that's good to know, because on worldview, we can argue. If this would be a scientific fact, we should probably have a moratorium on AI research. And so there are people who argue with them. For example, Timnit Gebru, who was an AI ethicist at Google, or Yann LeCun, who won the Turing Award for his contributions to AI and deep learning, now chief scientist at Meta, chief AI scientist. They say this is all based on long-termism, on the test wheel package, and it's ridiculous nonsense. Pretty plain statement. Good. So this is the basis for the fears on AI. Does it mean there are no risks? Oh, of course not. It just means these exaggerated hypothetical risks of, oh, we could go all extinct. You only have to be scared of that if that's your worldview. If that's not your worldview, you're fine with respect to this risk. And I think that's a good message. Now, coming towards the end, AI and us. Many people, especially when they're having the test wheel worldview, see us like the tortured Morpheus, and AI something like Agent Smith in the Matrix. All right? So let's debunk this view and put a couple of hypotheses against it. My first one is AI is a tool. That's what we actually have scientifically. We have functional learning, function approximation, and the products built out of it. It's a tool. It's not a counterpart for us. It's not a you. It's an it, period. It's more likened to the hammer than to the all-powerful cyborg or something. This we have from entertainment, not from science. And the only way it is connected somehow to the technology we currently have is because of the dualism of the term. Like, this is AI in the empty phrase meaning of the 23 characters. This is AI in the scientific meaning of the 23 characters. Okay, next one. The hype that is currently created, including the fear-mongering, might have altruistic philosophy behind it, but it's also quite helpful if you're the current leader of the pack in business and want to raise your next $6.6 billion, as OpenAI just did. So currently it helps your business. So I would make a question mark behind all the altruistic ideas behind some of the statements people make. They also they're also involved financially. Let's put it like this. So let's turn to some real risks. More immediate, humans are actually already losing against a subtle manipulation by algorithms in the name of profit. And we don't need ChatGPT and any advanced AI for this. We need the very, very simple and quick reacting algorithms that, for example, Facebook uses to rank your timeline, to rank certain posts up. Like, why are our societies diverging? Maybe also because we are all shown different news in our feeds. You can look up on this in the brilliant documentation, The Social Dilemma on Netflix. It's a shame that it's only on Netflix, but that one is brilliant. It shows how social networks are by design made to make a profit for their owners. That's only fair. I mean, it's a company. But to make a profit, it has to engage us with the platform. And to do this, algorithms learn what we engage most with. This is predominantly what we dislike and sometimes what we like, and then it shows us more of this. So it shows you what stirs you up in the positive or negative sense. It doesn't care. It creates clicks. So this doesn't need any advanced AI, and probably we should do something against it. And my question mark at the moment is, and I'm not at all an expert on that, is when we're talking about AI regulation, what is in principle a very, very good thing to talk about regulation of stuff that is changing stuff on a societal and planetary scale. Really wondering why nobody is looking at business models. Like, people are looking at what kind of models should be regulated, so technology or uses. Okay, yeah, maybe there should be some guidelines, guardrails of how the state should be allowed to use it, not to end up in surveillance. But I think we should be looking at business models. Like, should it be okay to make a profit by manipulating larger parts of society? Maybe it shouldn't. Or we should find a solution to that. That's not specifically an AI problem, but AI is part of that, and machine learning. Now, the midterm risk, I will spend the last few minutes on that. The midterm risk, the largest risk I see with AI, and many of the risks we are not talking about in education and misinformation and so on, are things where there are good ways of mitigating them. So the real midterm risk that I see is that AI might lead to a situation in which we humans, one by one, but in the end, a larger part of society, stop exercising agency over our own lives. Why? Some, because they feel intimidated. They hear all the talk of, oh, we are just biological computers, and then we see how the other silicon-based computers are super fast, and they don't forget, and they don't make errors, and so on. So they feel intimidated and lose a sense of, I can change things. I have my fate in my own hands to some degree. That's the one direction. And the other is AI in the best sense can lead to a lot of convenience. It can automate certain things. It gives us more time, maybe even more money, which is all good. It gives us convenience. If I look at the track record of us humans dealing with convenience, we are not super good at it. Like, the plenty availability of food leads to many people being too fat. The plenty availability of entertainment leads to people sitting there and just consuming and binge watching on Netflix and doom scrolling on social media. And what do we have? We have a crisis of psychological diseases in our young. We are not super good in dealing with convenience. We could, but somehow we are not strong-willed enough. So what we should do probably is strengthen human worth and value. Now, my last slide is about how can we do that. And that it is a good idea was already uttered by former Cambridge professor C.S. Lewis before he came to Cambridge, actually, in The Abolition of Man, 1943. He wrote about what a society could look like and where we delegate towards something like a machine. He said, if we abolish what makes us human, that will not lead to any good thing. So how can we hold up the worth and the value of humans, strengthen this so that every one of us, and so also society, can live in a good future where AI is not the main thing, but just one interesting tool amongst others, like heating and housing and education and so on. I wrote a little bit about that together with colleagues from the University of Fribourg and here Cambridge, now Oxford. in an article that appeared last December in AI and Ethics, where we trace the implications of the availability of such a powerful technology down to questions in the humanities that have to deal with what's our value as humans. Now, the paper somewhere stops there with a lot of open questions, and I'll go one step further and give a little bit of personal answer to that. And that is also inspired by faith traditions. Whether you believe that or not, what we can all acknowledge is probably that this was very, very important for how our Western culture works. Like the Universal Declaration of Human Rights is based and rooted in the thought that humans bear the image of God, that humans got a spirit from God. I'm currently reading a book by Cambridge machine learning professor Neil Lawrence, who writes somewhere at the beginning that while he's not a believer, he likes the idea that we have a spirit that distinguishes us from machines. In a book called The Atomic Human, that is all about what distinguishes us from machines if machines slice away in terms of capabilities a lot of things that were thought to be human. So this bearing the image of something higher, having a spirit in us, seems to be a good foundation for human worth and value. Now, going further, some insights also from faith traditions, and can also get it from the social sciences and so on. What makes us human? What contributes to what makes us? It's not a complete list. It's just 3 observations. Being human is characterized by relationships. We are relational entities. We do not work in isolation. Like even those of us who are introvert and do not like to go to parties and so on, completely alone is for forever is not good for everybody, for anybody. So relationships are super important for us. We need to be connected. The more connected we are, the better our relationships are, the better our lives are. We have to embrace our limits. All our learning is basically has to do with embracing some sort of pain. If you, I'm sure you could show that physiologically, that learning basically is a similar experience to having some pain. If you exercise, you have sore muscles, but the next day they grow. So in order to mature, we have to voluntarily embrace some difficulties. And if AI is a thing that does away with all the difficulties, that's a problem. Finally, I'm not sure if it's a basic human characteristic that we work for money, but it's a basic human characteristic that we take on responsibility, for example, in our work. So these 3 things, taking on responsibility, embracing voluntarily some limits, and strengthening relationship, this is what makes up humans. So in order to have a hope-filled, good future, and I think this is super in the possible, we could, for example, also, and that's just a crazy idea, not completely thought through yet, but we could also use a technology. Why not? You can say this is solutionalism and whatever, but why not? AI has capabilities of manipulating. We see that in the negative and social networks. Why not use a technology also to help us with these things, strengthen relationships? I mean, that was probably the good-willed idea behind social networks, just done wrong because of the financial incentives. Why not use AI to help us nudge us into the direction of embrace maturing, embrace character development? Why not use AI for things where we take responsibility for? And with this, we can help a very, very hopeful future. If you trace the word technology back to its roots, I was once told by somebody who was more knowledgeable in the field than me, that it comes from 2 Greek words techne and logia, techne, arts and craft, logia, where we get the word logic from, words, specifically also the words of God. You can basically, if you take it like this, translate technology as the arts and crafts of applying the words of God to solve problems. Well, I guess we have a couple of problems in our society. Not all can be solved by technology, but maybe some. So let's try to do something good with it. And at the end, I could sum it all up with this article that I found just this morning. Understand AI for what it is, not for what it might become. But here are a little bit more elaborate conclusions. We need positive narratives for a future, not some doomsday, we are all going down, we are the last generation, everything will die. Why? Because if we cannot imagine a future, we cannot go there, we cannot build it, not as engineers and not as a society. We have to have positive visions of where can that go, and not everything is at its end. And I think we have to be outspoken about our worldviews, first because everybody else is also doing it. And I guess a faith perspective is currently lacking in society when we look into these eugenics stuff. Thank you very much. Sorry for going over time.
Thank you, Thilo, for a marvelous whirlwind through what does AI mean and what does it not mean and what might it mean for the future. We have limited time for the formal part of the seminar, but we do have time for 1 or 2 questions. If you have a question in the room, could you put your hand up and wait until a microphone gets to you?
Thank you very much for your lecture. In the field of robotics, there's some talk about things that we ought to have robots do, things that are dirty, dull, and dangerous, for example. Do you have an idea of a similar kind of quick, easy to explain kind of bulleted list for the kinds of things we ought to be having AI do in that initial kind of definition of AI, things that we ought to be looking to technology to do for us?
We could use something similar. I guess also in the world of professional work, there are things that, well, we do them because they pay for a living, but otherwise we wouldn't be interested in doing them. So I recently saw 2 articles in the same newspaper on the same day. One was lamenting the fact that people have to work in call centers because it's a dull job, cold calling people and trying to sell a product that nobody wants. So that was one article. A couple of pages later was the article that was lamenting the fact that now call center work is automated by some AI voice assistants for those kind of things where that works. And the guys, please decide. Like either it's a job that no human should have because it's beneath us, and we are happy for automation then, or not. So there are certain things that are similar to robotics, but I think I wouldn't stop there without having a phrase in 1 sentence for it.
Thanks so much for your lecture, and I appreciate and agree with your vision of hope, and also that this should be informed by worldview rather than this idea that technology sort of holds an invisible, it becomes an invisible sort of just part of what we do, rather than being examined properly as part of our worldview. But I just want to ask you a question about your risks, particularly the second risk, that if you extrapolate that out a bit, and if we ignore, as you say, the science, the sort of science fiction definition of AGI as this transcendent being that sort of comes to control humanity. But the question I have is could you possibly get to in a similarly approximate situation with AI just being used as a tool scientifically as we have it now? So I'm thinking of the vision of the Internet of Everything, which is this idea that you connect up people and things. So all the Internet of Things get connected up into this rich network. So with biotech, human bodies become rich nodes in this network. And so AGI becomes, a computing force, which can actually then connect up that world. So you possibly get to a point where AGI doesn't become the transcendent God of that world, but it certainly becomes part of its control mechanism, whereby you then live in a society where the risk is not just a lack of morale or will, but actually that you're sort of tied into a deterministic. So you're staying within the scientific definition of AI as a tool, but it's such a powerful tool that allows that level of control.
I guess that in a few years from now on, the definition of AGI will have changed so that it fits these powerful agents that are still based on statistical learning and improvements of that. Had their shortcomings, were completely different than us, are not all powerful or knowledgeable, but are, well, helpful enough. And will that pose new risks? Yes, it will. Like every new technology, like how many risks did we get by having motors in vehicles for weapons and so on? A lot. But I see there, this is something that's not a completely different kind of risk. The super intelligence kind of risk is a different kind of risk. It will be so much smarter than us that we have no clue of how to react. We are basically like the ants towards the humans, and that's the current, how the risk is currently formulated, the superintelligence risk. This other risk, I think we will have time to gradually adapt to. I mean, we already have that. You cannot control a nuclear power plant without computers. You cannot control a spacecraft without computers. It's somehow embedded into inner workings of many things, and it will also be embedded, I guess, into how do we in policy in how a state is run, how larger networks of things are run, including things in the society. But I think this is a risk somehow related to risks we know. So I have some trust in our institutions and experts to find ways dealing with that. We found that, for example, with respect to bias. You probably heard about bias in AI systems, very prominent in face recognition systems that were very good to recognizing people like you and me, because we are somehow what the majority of the training set looked like, white guys in the Middle Ages somewhere. And if you were a child or very old or having darker skin or whatever, you had a lower probability of being recognized correctly. If the police is using such a system, that basically means every time you pass a police car, you will be examined. And if you're white, you will never be examined, even if you're the evil guy. So that's a problem, but and it was a huge problem. It was called out as such in around 2015, 16, 17. Also, we did some work on that. But it's technically very well understood, and it's also very well understood of how to deal with it. So every organization that is nowadays using such a system could know everything they need to know in order to build a system that is unbiased, and test for it, and test for the effects of it. So these are risks that can be mitigated, and I think the risks you mentioned are also in that area of are able to be mitigated.
Thank you. We will need to close the formal part of the seminar now. So we'd like to thank Thilo again for his wonderful talk. And I'd just like to mention, do look at our website, which will tell you about the further seminars in this series. And I'll highlight one particular event on the 14th of November. We usually have a public lecture every term. This term, we're doing something slightly different. We're showing a documentary film, The End of Humanity, which has an AI theme, and then there will be a panel discussion afterwards. So do look on our website for the details of that and the other events we're doing.